Welcome to my fifth video outlining my SaaS project. Uh, in today's video, I will talk about the importance of solid and the use of design patterns and why they are beneficial. In the previous video, I walked you through my relational model and introduced you to the persistence layer of my application. Before I start showing my code, I want to set the foundation by covering solid principles and design patterns. These principles make code more maintainable, flexible, and scalable, and this is crucial when building a SaaS platform that will evolve over time. By understanding these up front, the decisions I make in the code will hopefully make a lot more sense. Solid. What is it? Why should I care? So SOLID is an acronym for 5 design principles and design patterns developed by Robert C. Martin, or Uncle Bob is often called. The acronym was actually created by Michael Feathers a few years later. Uncle Bob is an industry titan who has written several books and courses. I highly recommend you check him and Eric Evans, the creator of DDD. Check them out. So let's dig into what it stands for. The S stands for single responsibility principle. This means that a class or method should have only one responsibility or reason to change. This is important because classes with a single well-defined responsibility are easier to understand and modify. They are also easier to test since each class is one job instead of handling multiple concerns. By keeping responsibilities separate, changes in one part of the system won't accidentally affect unrelated functionality. It should be noted that it doesn't mean the class or function can only do one thing, such as write to a file, but that its constituent parts are all related around the same concept or context. I wouldn't put the code to save a tenant on the tenant class. That will give it 2 responsibilities. Persisting data and tightly coupling the class to a database means that if the database changes, a tenant entity will have to change. And also the concept of a tenant may evolve and need changing to match those needs. The O stands for open close principle, and this means that an entity should be open for extension but closed for modification. This makes software extensible, new features can be added without modifying existing code. It becomes more stable as the risk of introducing bugs when making changes is lessened. And it also makes the software flexible as we can adapt to changing requirements more easily. So let's look at a simple example. Here you can see we have a discount service class. It has a method apply discount, and there's an if statement that decides how to discount the given customer type. So if we introduce a new customer type, then we'll have to modify this class and method. So this violates the open close principle, and every time we modify the code, we could break this existing functionality. And to solve this, we create an abstraction. So, for example, interface called customer discount with the method apply discount, which takes in the price. We can then create a concrete class of this interface with a different algorithm that each scenario requires. So unregistered customer just returns a price. Basic customer gets a 95% discount, and forgot to change it here to get gold, a different discount. Um, um, and as the new service here takes in the interface in its method signature, we don't care which one of these classes were passed or provided. We can just call the method on the interface. And the implementation of the class is abstracted away from us. So this makes the code open for extension and closed for modification. So this not only demonstrates open close principle, but it also demonstrates the strategy pattern. And this pattern is about defining a family of algorithms, encapsulating each one separately, and making them interchangeable at runtime. By separating discount logic into individual classes, we can swap them in and out without modifying existing code. None of this, just a new class. This is one of the 23 Gang of Four design patterns, invented back in the 90s, I think, by four fellas from IBM. Early in my career, the importance of the book, design patterns, elements of reusable object-oriented software were instilled in me. I think developers should be familiar with at least some of them. They are split into three categories: creational, structural, and behavioural. And they outline methods for solving common problems in software development. So the L stands for liskov substitution principle. And this basically means that a derived class should be usable in place of its parent class without the calling code knowing it. And this enables polymorphic behavior, making code more flexible and reusable. It ensures that subclasses adhere to the contract defined by the parent class, and it provides predictability as we can guarantee that we can replace the parent class with a derived class and not break the application. Next, we have interface segregation principle. And this says it's better to have smaller focused interfaces rather than larger ones. For example, if we had an interface with 10 methods and we have three classes that inherit the interface, if class A and B only implement concrete implementations of a few of the methods, the ones that don't make sense to the class will have placeholder code in them, such as throwing an exemption. Not to mention this violates the SRP, single responsibility principle, as the class is doing more than it needs. And by implementing this principle, we will help to decouple our code by reducing dependency between classes. The code becomes more modular and maintainable, and flexibility is introduced as we have targeted implementations of interfaces. And finally, we come to the dependency inversion principle. This means we depend on abstractions and not concrete types. This helps us further decouple our code as we reduce dependencies whilst making the code more flexible and easier to test. And we can swap in implementations without affecting clients. For example, I abstract away my database code. I can swap in a test in memory database and run integration tests, or I can write unit tests against the interface. We saw an example earlier where we changed the service to take in the dependency. Yeah. And I've previously mentioned the Gang of 4 and 23 design patterns. And during this development, I expect to use the following patterns. Strategy we've already discussed. and I expect that we will use factory method, abstract factory, and the decorator patterns. So the factory method is a creational design pattern which defines an interface for creating an object, but it lets subclasses decide which class to instantiate. Instead of instantiating an object using new, um, the factory method delegates this responsibility to a method that subclasses can override. Um, so factory method. This is how I apply the factory method in my integration test. So in my database fixture base generic class, I define a factory method called createDBContext. Um, Subclasses like tenant repository class fixture override this method to create a specific database context instance for testing. In this example, that would be test tenant and management context. This ensures that my tests remain flexible and reusable while keeping object creation logic encapsulated. The key concepts and benefits to the factory method is that when encapsulating object creation logic and preventing direct instantiation of a class, we ensure that our code is loosely coupled. We're depending on an abstraction and not a concrete type, so we have reduced our dependencies and improved maintainability. We adhere to the open close principle as we can introduce new types without modifying existing code, thus making it more example. You'll see more examples of this when we deep dive into the individual APIs and cover the tests in detail. Pardon me. Abstract factory. So this is another creational design pattern that provides an interface for creating related or dependent objects without specifying their concrete classes. And I'm going to show you an example that I cribbed from Refactoring Gurus. And this is an excellent site with very easy to understand examples. I highly recommend learning some of these patterns. So you declare a set of interfaces. Here. And then you create concrete products. And you can have a factory that builds them. And here you can see you have a Victorian furniture factory, a modern furniture factory. And these that create chair, coffee table, and sofa. You can rely on this interface as it's passed through to generate them. So you're not using the concrete types. Next we have the decorator, and this is a structural pattern that lets you attach new behavior to an object without affecting the current behavior of the object. ASP.NET Core middleware follows the decorator pattern quite perfectly. When a request comes in, passes through multiple middleware components, each one adding behavior such as authentication or login. Each component wraps a request, processes it, and then passes it to the next. Just like decorators wrapping an object. This lets you extend behavior dynamically without modifying existing code. Basically, you wrap the original object using the same interface. Like a Russian nesting doll, you can keep adding behaviors. This is some middleware, and this is a method that you call an interface. It's these solid principles and design patterns that are the foundation of writing maintainable and scalable software, especially in a SaaS environment. As I continue to build out this platform, you'll see these principles in action. If you have any questions or thoughts on solid and design patterns, drop a comment below. I'd love to hear how you apply them in your own projects. And if you don't want to miss the next video where we start diving into actionable code, make sure to subscribe.